Okay, awesome. This is a small enough group for me to not go into like a long uh, uh, sort of tirade into what we're doing. So as long as it's just these many people, if you guys want to jump in at any point, if you want to ask a question while I'm talking, feel free to like unmute yourselves and go ahead and do it. Awesome. Yes, see my screen. Yes. Okay.
Yes.
Right. I'm Akshay, co-founder at Dplan Proto. We're building a proof of location for Solana. And I'm going to walk you through very quickly what proof of location is, how it works, and how you can use the API. And if you have any questions, like I said earlier, just feel free to jump in, ask, and we can take it from there. Okay. So Proto is a social life logging app and an API for proof of location on Solana. It's essentially uh, there are a few issues that we were trying to address. One of them being that spatial data has no on-chain primitives. There's no way to deal with spatial data on-chain. The most common way that people do it is that they just append it to an on-chain transaction and upload it online. But that does not really provide it some sort of a unique identity. It can be sort of repetitive and there's no reason to sort of consider it unique in any way. So simultaneously, location itself, when we share location data, the process is highly opaque. It's centralized, owned by a few people, and there's no reliable way to sort of get it apart from using, let's say, GPS or IP address. So for both of those things, what the API does is that we secure physical locations on chain, create an identity for them, make sure that their location is tied to their on-chain identity so that those two things are not separate. And you can correlate location with different things that happen out on-chain related to that location. And we let you substitute GPS with localized triangulation. Uh, so the product has three parts. There is a social app, which is what we use to sort of build further validity into the data that is going on chain. There is an API that you can use that you, as developers, can sort of just sign up for and incorporate into whatever you're building. And there's proof of location, which is sort of like the protocol where trustless verification of user assets, places, and movement happens. So the app is pretty straightforward. It's kind of like a social check-in thing where you can go to a location, you can say, oh, here's where I am. This is what I'm doing, and whatever. You can basically take that as a starting point, and you can build your own experiences around it if you want, if you are a creator or even if you're not. But eventually what it does is that gives you enough data to understand geospatial patterns that wallets have in real life, how wallets behave in real life. The API is kind of simple as well. It's built out on the basis of GeoJSONs, which are universally sort of the accepted standard for sharing location data. You can, which makes it sort of composable across chains. You can use a location identity that you've created on Solana, and you can possibly move it to Ethereum or whatever. It can also sort of allow you to correlate with someone else's program, which is built out on location as a GeoJSON. But the application layer eventually becomes sort of a single point source of truth for all location-based transactions that happen on chain. And then there is an ownership layer, which we haven't sort of which is not like really available yet. But the ownership layer is basically the layer which allows you to sort of create a protocol for real-world asset ownership on chain. And this is what I'm going to talk about mostly today, which is proof of location. Proof of location is something has been sort of been discussed a lot in the past few years, I guess. But there's few people working on it. We're one of them, and there's no real composable programs out there that sort of do it the way we do. Proof location for us in Proto, it's multimodal. We rely on sort of a series of different systems to triangulate device locations. It's built into the API, so you can sort of when you use the API, you have proof of location available for you. Uh, and it allows you to sort of build out custom solutions. You can deploy your own nodes if you want to, not necessary. You deploy your own nodes for sort of arriving at establishing proof of location, and you can build further for it. I'm not going to talk a lot about the infrastructure and how the API works. I'm going to really sort of go through it very quickly, but I'm going to sort of spend some time talking about proof of location. That's the complicated part here. So the API has sort of 4 components, really. There is a GeoJSON, there is check-ins, and there is map logic, and there is search. All 4 are sequential. You relate with each of them. You sort of create requests progressively based on what you need. And it allows you to do basically whatever you want. Proof location. So proof location for us is done using something called time difference of arrival. Effectively, it means that there are decentralized nodes around you, depending on where you are. They're either LoRaWAN nodes, which is low range wireless area network. They're either Wi-Fi nodes, or there are 5G CBRS nodes. These are all nodes that are run by Helium. And we use those nodes, we use the relationship that node has to your device, the device that you're trying to triangulate, and arrive at a, and try to verify your location. So depending on the kind of device you're using, the method for triangulation is different. For tags, trackers, IoT devices, it's typically the Helium LoRaWAN network. So you do need to be in proximity to a Helium LoRaWAN node to be able to pull that off. In the US, if you're using a phone, across the US, you can be triangulated using 5G CBRS. CBRS is a different spectrum of 5G. It's not the traditional 5G that is publicly available. It's a different spectrum that Helium uses for its 5G services. Wi-Fi hotspots, which Helium is still sort of rolling out in the rest of the world. In the US, they're available. And depending on sort of how accurate you want it, the minimum number of nodes that you need to be in proximity to ranges between 3 to 7. 3 being the minimum, and 7, I mean, there's no maximum limit, but 7 provides you some sort of an accuracy level that can sort of reach towards the lower range of millimeters. So effectively, what when you use the API, you create requests for check-ins. Everything that you do on the API is a check-in. A check-in is basically you sending your user's location to us and asking us to verify if this location is accurate or not. All check-ins then are run through our API. They go towards the Helium network. We try to find the closest POC coverage that Helium has established. And once we've done that, we triangulate a location. We send it back to you, telling you how accurate that location is, provide a verification score, and we let you know sort of if you have any additional sort of map logic requests that go with it, we sort of respond with them. So I'm really this is basically what I wanted to talk about. I'm really at the end of this presentation, but I want to throw it open, because if there are any questions, I want to talk more, sort of spend some more time addressing them than sort of keep going on this long rant.
Yeah, anyone with a question, please do feel free to drop in on the chat in case you're shy to talk.
Hey, Akshay. What sort of coverage? I may have missed this, but what sort of coverage do you have? Well, actually, let me start with this first question. So if you have 3 nodes, what sort of accuracy would that typically give you in terms of meters or kilometers?
So it depends on the device that's being triangulating. For IoT devices, if you're using LoRaWAN, 3 nodes it's also sort of related to the distance that you have between you and the node and the environmental condition, because how many trees there are, how many buildings there are, etc., etc. But on LoRaWAN with an IoT device, you can get an accuracy of about 5 meters with just 3 devices, and that's just because LoRaWAN is great at sort of cutting through density. On 5G, if you're using it in an urban environment, you're going to be able to get an accuracy of around 15 meters with 3 nodes.
Okay. And then my next question then was what sort of coverage do you have? Let's say in the US and Europe, where I guess a lot of my company's customers would be. Does that apply even if you're out in the middle of Montana or something like that 15-meter claim?
Yeah. So in fact, so again, depending on the device and the sort of network that you're trying to use, if you're in, so let's say you're in Montana and you're trying to do this for IoT devices using LoRaWAN, then devices that are even 30 meters away from you, even sort of a kilometer away from you, might be able to triangulate you, because Montana is so easy. It's
okay. So in
an
fact,
expanse of open space.
so it's the density of nodes isn't only one factor, but actually in like deep in the countryside, there's you're going to have more accuracy. Okay, very cool. And the last question from me then, what's the sort of turnaround time in terms of like I haven't seen how this is hooked up to a front end or anything yet, but if let's say the user clicks like verify my location, it finds nodes, it triangulates, it sends that information to your APIs, you come back with a score. What's the sort of turnaround time for all of that?
So if you are in proximity to a node, and if we are able to triangulate it, it takes about 3 seconds.
Okay.
And we're trying to improve that. But if you're not in proximity to a node, or if you're in proximity to like 2 nodes and you're not in proximity to the third one, it takes a little longer because the program tries to search for another way to sort of triangulate you.
Okay.
Which is
there's almost like a network.
Right.
There's almost like a gossip network between the nodes or something like that. Helium.
Yeah. Helium has something called proof of coverage, where each node speaks to another node at a regular interval to prove that it is exactly where it is.
Mm-hmm.
So the nodes are already triangulating each other amongst themselves. So we rely on that data. So we go into your closest node. Your closest node tells us which the other 2 closest nodes are, and those tell us which the other closest nodes are.
Cool. Very cool. Nice. Thanks, man.
Thanks.
Akshay, in case there are no other follow-on questions, you could walk through different kind of applications that can be built on this, like use cases, because it would be relevant. We'll share the recording with the rest of the participants. For building on
Absolutely. Just give me a
your,
second.
Sure.
So if any of you here are building on for the hackathon, I'm going to just give me a second. So I'm going to get you a link where we have a page for people who are using the API. We have a page where you can sort of refer to sample ideas, and it's part of the docs as well, but I'm just going to share it. Can I send it to you, and can you, oh no, I can just send it here. Okay, I have access.
I think you're
awesome.
sharing.
Yeah, I just shared it, but I'm just going to.
Maybe you could just walk through that as well. Maybe
Yeah, I'm just
a bunch
going
of
there.
use cases. Yeah.
All right. So a lot of these are sort of, if you're beginning to build with the API, some of the stuff that you see on the screen right now is a little bit difficult to build. You need to get used to how if you have no experience dealing with maps, and if you have no experience dealing with geospatial data, it'll be a little difficult to get there. On the most basic applications, if you look at the link that you can build, and that I think we encourage you to try out, is to build a geofence transaction app, I guess. Point being that you define a particular boundary on a map, and you say that only people who are within this boundary can perform this transaction. And that's sort of the really most simple, most basic way to pull this off. You define a boundary, you send it to us. Every time you want to verify whether a person is within that boundary or not, we tell you, and then you can sort of process your transaction according to that. It's a great point to get started, because once you're used to that, it'll give you enough experience building with geospatial applications so that you can add on to it and you can do other things with it, and you can sort of create whatever you want. But just on a broader sense, the things that you can do if you have more experience with this kind of stuff is gaming, which is sort of the most direct and obvious thing that comes to mind when I talk about it, is Pokemon Go, which is why I have Charmander there. But the other thing that you can do is refi MRV. A lot of MRV stuff that people do today is either done as post, sort of once you utilize it to sort of utilize sensors to sort of gather data. You use that data and you then sort of analyze it and whatever. And if you think that data has certain value, you put it up on chain and you do whatever you want with it. There is no trust or verification done in this process. And one of the things that Veera needs right now from anyone, if they want to sort of build and completely on-chain data collection MRV process, is that that data needs to go on-chain immediately and it needs to be trustless. Yeah, I would scream too. The method that you can use is to basically sort of provide each of your sensors with an on-chain identity, use that identity and append your check-in. Each check-in then can have data appended to it that the sensor is trying to push on chain. So for example, if you have an NPK sensor, which are sensors that are used to collect nitrogen, phosphorus, and potassium data from soil, this sensor sort of captures data regularly, pushes that and processes that data, let's say once a month. Once a month, you ask that sensor to perform a check-in. It performs a check-in and that data goes up on chain and it pushes all that data, all the NPK data that it has collected with it up there. Now, once it's up there, you can either keep it and you can use it and do whatever with it. And if you don't want it, you can just push it to cold storage, send it to like IPFS or Filecoin or whatever you use it for. Another place where this is actually already used very commonly is supply chain and logistics. So a lot of organizations that want to sort of privately track assets that are moving across the world, shipping companies and things like that, tend to have their own tracking solutions established. A great example is if you look at the Suez Canal or Panama Canal, canals which have a lot of shipping happening through them, will typically have their own tracking systems established. They'll be the most common way that these people do that is to use BLE, Bluetooth beacons, or they use sort of some variation of what we call air tags, which are publicly available now, and they track those assets as they move across space. Location-based transactions, like I said earlier, it's kind of the same. Geofencing things is possible. And land-backed stables is something that we are a little far away from right now, but it's definitely something that can happen. It depends entirely on the context that you're operating in, the legalities, compliances, and things like that. But effectively, it's a mechanism to say that, there's this expansive land that we have. You can use that to create some sort of stable currency that the people who live here or the communities that own this can utilize for whatever they want to utilize it for. But yeah, I think apart from these, a lot of sort of custom solutions come up when you think about how asset tracking happens, particularly in the case of logistics and supply chain, because that is where this is most commonly used today. Yeah, I think those are some examples that I have. You can also use proof of location to build an identity layer to verify a person's location and use that as a combination with KYC to sort of create a verify identity, things like that. There are more examples within that link